Can you see? Okay, great. All right, welcome, guys. We'll address that later. Welcome, guys. So today we'll start a new topic on data structure. Now, data structure it's very different from data type. We'll be doing data type or use. Yeah. I mean, of course, I know most of us we watched the video I sent to the WhatsApp group. I think that's what we'll be doing now. We have videos on the YouTube channel. So anyone related to um, uh, come on, guys. How do you know if your account has been worked on? It's simple. You will see that the number of people who have access in your folder they are reduced. They are not much. And that's how you know. And if you see any email outside the one that we said don't remove them. That's it's as simple as that. So um okay. Is that clear? All right. Okay, great. Thank you. So we'll be doing data structure. We are be doing data type rather, Boolean and the rest. So I was talking about the YouTube video, or I got distracted. So going forward, anytime we have class, I will send the YouTube video to you guys. Okay, so I'll be handling to this class all the way from my 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 location where I am. So let's look at what is data structure. Now, data structure, it looks like before when we say put a variable to assign the value to a variable, it's like you're assigning one value to a variable, name, age, and the rest. But data structure gives you a little bit of flexibility where you can be able to add collections of values. And it's in different type. We have list, we have tuple, we have set, we have dictionary. So these are all the data types structure that we have for data structure, the type, the kinds. And we are going to be looking at them, as the class progress. But today we want to focus on list. Now, list, the reason we're focusing on list is that if you understand list, it is easy to understand tuple, set, dictionary. So list is like the fundamentals, the no, let me first say fundamental, look like it's something new. It's like the building block for data structures. So that's why we are starting with the list. So I want you guys to pay attention. It's going to be very long. I'm taking that we started 9:30, so it's going to be a very stressful one. Uh, so everybody stay in class. So what is a list? A list is a collection of values that can be of the same data type or not. So a list is a collection of values that can be of the same data type. Connect. That can be of the same data type or not. So this place I made a mistake here. Let me correct that. Great. So I said a list is mutable. Its items can be modified or changed. So first of all, is that a list is a collection of values. You use a list to collect values. It can be now that values can be of the same data type. You know what is a data type already. So they can be the same, you are collecting float, integers, all of that can just be in a list, or they can be mixed inside a list. Then the next thing again you should understand is that a list, the value inside a list you can change it. Meaning in that collection of list, you can change it. Let me use another example. Um, there's a word called array, but I don't want to call list as an array because when we get to array doing numpy, you find that it's totally different from a list. Although list is the foundation of it, but it's similar to rather like like an array where you have stack of things being put together. Uh, sketch. So I sketch. Right, so this is my go to drop. Great, great. Oh, sorry about this. Not confuse you guys. We'll clean this off. Okay, let me just create a new one. New one. Great. So the color should be green. All right, great. So this is a stack. Let me draw. This is a stack. Let's say this is a stack, right? You have maybe things inside it like this. See, inside, inside, inside. So you can have an item one, or normally item one, item two, item three, item four, item five, and then six, and then let's go seven. So the first item that entered was this. So that's why it's inside the list. So like this stack, that's what you call the list. So vertical wise, this is it. But horizontal wise, it can go like this. You already know. So we have one, and we have two, we have three, four, there could be five, there could be six, and sorry, there could be seven. Great. So it can be like this. So that is what a list simply means. So how do we create a list? We create a list this way. Let me put that up here. You create a list with these brackets, this open and close brackets. So we have fruits is equal to this open and close bracket. That's a way. This is an empty list. Anytime you see something like this, we call it an empty list. So let's run it. Then we can print it if we want to. So print fruits. Let me make my screen a little bit bigger for you guys. I think this is okay. Can you hear me, guys? If you can't hear me, then it's your audio. So it's your audio, Kesley. So fruits, you can print fruits. See, it's showing empty. And you can also do type. Remember, I taught you guys this thing, type, to find out what is the data structure of that fruit. So you see it's a list. So this is what you use to build an empty list. Great. Now let's populate it with items. So this is we populating it with items. So we've added all of them are strings, but that doesn't mean we cannot do something like this. List underscore list is equal to, can do name 20 45.6 true. So you see, if you run it, it will work. Great. And you can just, let me just write list. If you do it like this, it will also work without writing print, as long as it's just this stuff. So you see it's working. Name and the rest. You can also do the type of it. Just do type. You can also do type, and so type is a list. So a list can contain different data value. So this is another list where we have banana, orange, mango, grape, and cherry. And if we print it out, great. So we have it. Now, one thing I need to tell you guys is that list is ordered. Yeah, a list is ordered. What it means is that every item inside a list has an index. Every item inside a list has an index. Just the same way we have this. This is a list. Every item inside this place, it has an index. So normally, let me come. Scroll up a little bit. I think I can scroll up a little bit. I think I can carry this one here. Level together. Okay, so what I want to do is this. Let me show you something that's in this list. The first position we have here is this. This is position one, right? because this is the first thing that entered the list. This is position 2. This is position 3, position 4. This is position 5, and this is 6. This is 7. Now, don't confuse this position. Don't confuse position with the items. Everything inside here is called item. That's what you have inside the list. This is the item. So it can be anything. It can be human being, rice, beans, whatever. But this is the position. This was the first one that entered. This is not -1. This is 1. These are the first thing that entered, the second thing that entered, the third thing, just go like that. But in list again, as we have position, we have what they call index. This is E, this is S. We have what they call index. Index starts from 0, not 1. So this is index 0, index 1, index 2, index 3, index 4, index 5, index 6. So practically, the size of an index is the total number, the length of the list, that is n minus 1. Because if you count how many is the list, 1, 2, that's the item, 1, 2, 3, 4, 5, 6, 7. So it's more like the length is 7. So 7 minus 1. Let me draw something else so that I don't confuse you people again. So follow me. Let me draw something. Let me draw something else. Let me to explain. So this is our list again. I want to create a new list. And everybody, give me your name. Just be calling your name for me. Let me use your initials. Call name. Sorry. Oh, you guys are muted.
Otaria.
Call names that I can easily spell, please.
Docas.
Kingsley.
Okay, I'll just say Kisley. K.
Paul.
K. L.
Gift.
Paul.
P. A. Okay. Gift.
Docas.
All right. G.
Paul.
F. F. A. Yes. E. F. E. I had Docas just now. So I'll call Docas DC.
Joy.
Joy. I'll call Joy JY. JY. Okay.
GT.
Huh? Somebody's whispering his name.
Collins.
Okay. CL. And
C.
last person.
Albert.
AB.
Albert.
Thank you. Albert AB. All right. Great. You guys are wonderful. You guys are wonderful. So this is a name. Let's say this is a name of students in this class. We have put the names of these students in the class inside a list, so that anytime we can come back and be referring to the names of the students that we have in class. Kisley, Paul, Gift, F.A., Dorcas, Joy, Collins, Albert. Now, let's assume that Albert was the first person's name that we entered in this list. So Albert's position is 1. Collins is 2. Joy is 3. Dorcas is 4. F is 5. Gift is 6. Paul is 7. And then Kisley is 8. So Kisley remains at the top because he's the last person to enter the list. So if we have anybody that enters the list, that person becomes 9. Great. So what is the length of this list? What is the size? The size of this list means how many values is this list having? 8, Abi? Okay, you guys have gone. Okay, no problem. Don't worry. If you don't answer me on time, I know what has happened. One of the admin, they've done their job. That's why they are here. Okay, so I've not heard from somebody. Bobby, where are you? Bobby, is Bobby here or? I'm not sure it's here. Oh, maybe it might be. Okay, so Bobby used to disturb me for a notebook. Great. So position is 8, thereabouts. That's good. That's the length. But the index, it's is a different thing. Index starts from 0, 1, 2, 3, 4, 5, 6, and 7. That's how index starts. So what index mean is that this is position, this is index. Let's call it int. What index means is that if you want to access any of these items inside this list, you use the index. You don't use position, you use index. So if I want to get a about, for example, now, I will do the list like I'll put it like this because a list is with this format. I'll put index, I'll write 0 inside. Then the name of my list definitely will be here. So let's say the name of my list is Ellie. So it will be L index 0. This will give me this guy to print this guy out for me. So that's what I am telling that the highest number of your index is the length of your list, which is n minus 1. And it's not just a list, though. It's the same thing for a tuple, it's the same thing for it's just for a tuple also, because set is different. But it's the same thing from your tuple and a list. It's the same thing. So you already get this clue now. Let's move back to code. So now we have printed a list, which is ordered. So we want to get the first item of that list. The first item is banana. So we'll do index 0. So I'm going to run this code. You see, when we printed index 0, it's bringing banana out because banana is what we have at the first place. Great. Then let's try to access this. We have 1, 2, 3, 1, 2, 3, 4, 5. So that index will be 0, 1, 2, 3, 4. So 4, which is the last, it should give us the last item. This is 0 for index 0, index 1, index 2, index 3, index 4. So to get the last item should be index 4. So I'll put 4 here. If I run it, I'll get share it, that's correct. But again, just the same way you can index positive 0, 1, 2, 3, 4, 5, 6 going forth. You can also index negatively. You can index negatively, meaning this one we are doing 0, 1, 2, 3, 4, 5, 6, 7. So the last index here to get the last item here is 7. But again, you can index negatively. You can do something like this: -1, -2, -3, -4, -5, -6, -7, and I think that should be minus. This should be -8 or thereabouts. Or you can just leave it at 0, whatever. This is the first item. You understand? You can leave it at 0 or possibly maybe -8. But the idea is this: is that if you do -1 by index, you will always get this. So what this means that on our code, we have done 4 to give us the last. Currently, this is the last item in the list. But you can also add to a list. And if you add a value to a list, it means that this one will not be the last item. Do you understand? Hello? Let me, guys, I need to respond now. So, great. So, this sherry will not always be the last item. It means that the value, the index can change. But no matter how any list is, whether it's changing or not changing, -1 will always give you the last item in a list. -1 will always give you the last item in this. So even if the list before, when you say, how do I say this, guys, so that I make sure everybody understand these things might go. What I'm saying is this: is that if we decide to add maybe this name to this place, It means that this name will be position 9. Great. Before, we have been saying that index 7 will give us the last item. And we say if we also use -1, it will give us the last item. But now this list has been changed. So this name now is not taking index 8. Great. So it means that if we use index 7 to say we want to get the last item, we are wrong. It has gone to index 8. So index 8 should give us the last item. But what me I'm telling you now is that why this is a little bit, it's the index is not so sure. Anytime that there is any addition to the list, you see this -1 here, it moves to that addition at that place. It will go to that place. So automatically this place resets itself. Here becomes -1, here becomes -2, here becomes -3, here becomes -4. So -1 will always give you the last item in the list. Whether you add to the list or you remove from the list, -1 will always give you the last item. So that is the best way to get the last item in the list, instead of using the last number of positive index to get the last item. Use -1. I know that thing. I know you understand it. I know you understand it very well. So let me go ahead. Let me go ahead. So the next thing is how do you change the existing value in a list? You can change the existing value in a list. For example, let me print our list here now. So these are lists. Fruits. We have fruits or fruits. So we have banana, orange, mango, grape, and cherry. What if you want to change banana? What you do is that if you want to change the item in the list, you use the index. So this one, I want to change orange. Sorry, this is not banana anymore because this is index 1. We want to change orange. Orange is at index 1. So to do that, you write the name of your list. This is the name. That's the variable name. You put this open. Always look at the bracket too. It's different from this parenthesis. This is normal square bracket. You put normal square bracket. You put the name, the index of that position that you want to change. That value you want to change. What is the index? Okay, this one is index 1. Okay, stay here. I want to change index 1 from orange to onions. So if we run this, you now see that we have banana, but orange has been changed to onions. Let me make it a small letter O and still run it. It will change it. So banana, instead of orange now, we now have onions. Very, very important. Okay, so let's move ahead. Now, let's talk about some method. I can't explain in depth what a method is because we have not done function, but just take it as a method is something that Python uses to help carry out some functionalities on a list or some function on a list or a task on a list. So a method is something that is attached to a class. That's actually the definition. A method is a function attached to a class. But we've not done method, we've not done function or class, so I can't be, but just get the idea. Remember, those of us we met on Saturday, I told you up and then we'll come down a little bit. So what are the methods that they've attached to a list? The first one is append. What does append do? It helps you to add item to a list. So we want to now attach an item to a list. You want to add something to a list. You use append. So it's the name of your list, which is the variable name, fruits. Dots. You use dots to call a method. Dots is what you use to call that function that you want to use on it. Like in this case now, somebody was asking me a question about object. Fruits is our object, and then this is our method. So we are attaching this append to this fruit. So what do we want to do? We want to add apple to our fruit. Now, if you do this and run the code, and you later print the code, you see what will you notice? What did you see here, guys? Apple is not added at the end of the list. This is the trick. Anytime you use apple, sorry if I said apple. Oh my god. Anytime you use append, it adds the value to the end of the list. Anytime you use append, it adds the value to the end of the list. But what if we want to add more than one values? Like we have another list, we want to add it to again to our an existing list. You can also use append to do that. So let's see, this is another one called fruit 2, where we have apple, orange, and pear. So we already add apple. So I'm going to take this one out, and let me just add another fruit. Let's see, which fruit should I write now that somebody would like? Banana is there, orange is there, mango is there, grape is there, grape is already there. Let me write lemon. Fine. So lemon. So we want to add these three things to it. So once we run it, I should do something like this, guys. Sorry. Print. This is what I should do. So it's work. I'm probably let me print my fruits. Let's say fruits. Okay. So print fruits are for us. Great. So you could see what has happened when we did this by saying fruits. We added lemon, orange, and pear, and then we append the fruit 2 inside our first list. See what came out. It gave us banana, onions, mango, grape, cherry, and then this is what he did. He added that same list, the entire list, at the end of our first list. In this case, this is what we call a nested list. A nested list is when you have a list inside a list. Nested if is when you have if inside if. Nested loop when you have a loop inside. Anything that you have is repeating. It's nested. You can even have a function inside a function. So this is a list appearing in a list. But one thing you should notice is that it has it just packed it like a list directly to the existing fruit list, So, but there's another method called extend. Extend is more like it does the job like an append, but in a different way. I'm going to copy this and then put it here. So somebody should give me another fruit. Let's just first of all let's extend just one fruit and let me see so that you guys can practically see what's going on here. So let's extend let's say which fruit should I put now that I love? Let me put tomatoes. All right, so I'll use, so let me use tomato. So if let's extend tomato. So can you hear me? Can you hear me now? All right, great. All right, so let's go ahead. So I said you guys should see what happened when I did tomato with extend. Can you see what happened? He splitted each word of my tomato. Extend splitted each word. It did not arrange it. It did not arrange it directly like the way append was doing. Let me do print so that I can. Let me say print fruit and run it so that I can scroll so that you guys can see what I'm saying. Look at what it did to my tomato. It just scattered every word, and as it scattered it like this now, every this one has its own index. Let me ask you guys a question by going back a little bit. If this is index 0, index 1, index 2, index 3, index 4, index 5, Hope we all agree that everything here is indices. You understand? It's not like this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Here will not be 6, 7, 8. No, everything here grouped together like this with append is indices. You understand? So that means that in this extent that we did, all of this thing, all of this one, if you can't see my screen, just my screen is visible, guys. Abby? So I'm not doing illustration, no. I'm still on my code, though. You see, you can see my screen with illustration. I'm not illustrating. So this would be a different index, but this is wrong anyway. So what does that tell you is that while append, you can use append to add one word to a list. It stays at the end. If you want to attach a group of lists, you want them to remain together, use it. But you can use extend. Let's use extend to add a list now to our list. So let me just use this fruit again that we have. So I'm going to run this code again. I don't know why I keep doing this. This is not what I should be doing. Great. So let me print. I hope I don't do it more than once. So let me print fruits. Okay, great. So this is what you see. I've done it more than once. When we use extend, to add this extra list inside this list again, you see that it splitted it out. Unlike the append group them together. But once you use extend, it will unpack everything inside that list. Just the same way it did for this tomato. You unpacked every word and put inside the list. That's what extend. You say I'm extending it. I mean, I want to extend my list with this word. So it's going to say, okay, no problem. For every word inside or every list item inside this list, I'm going to extend that one you are working on. But for append, it's like attachment. Just join up. Don't do anything. Just join up. So guys, you can play around with this. It's very, very important. So you can also find the length of a list by using the length function. This will give you the length of a list. So let's run this. Our list now is scattered. So you can see that the total item in our list is 19 because it's scattered. Let's count. This is 1, 2, 3, 4, 5, 6, 7, 8. Can I say my 8, 9, 10, 11, 12. Everything here is 13. Sorry. Everything here is 13. This is 14, 15, 16, 17, 18, and banana is 19. So you see, so once you use the length function, you get, so how do you do it? Length in brackets, put the name of the variable of your list. You give it 19. So you say it's even bringing it out. Fine. Let's do another one for how to add something to a list. We've seen that extend is still at the end. Look at it at the bottom. If you use extend, bottom. If you use append, the same part. But there comes insert for you. With insert, you can add any item at any position of your choice. Any item at any position of your choice. So by using the index, so you cannot say, oh, I want this item I want to add to this list. It should go to the first place. If you say you should go to the first place, meaning you should use index 0. If you say you should go to the second position, meaning you should be using index 1. You get the idea? So that's how you can do your stuff. So let me show you guys the practical aspect of it. Now, somebody gave us pineapple. Let me see it on the chat. Somebody gave pineapple. Screen lagging. Everybody just complain. Carrots, pineapple. Let me use pineapple for cost time first. Pineapple. So we want to add pineapple to our list. But this pineapple, let me first of all print our list out first so that you guys will see it. Print our list. That is fruits. Let's print our fruit out. Oh, not fruits. Get so banana is staying at the first position, but we want to insert pineapple at the first part. So it means that this pineapple should come first. So we run this part. Once we run it, great, we've done that. So let's print the fruit again now, and you will see where pineapple is staying. Where's pineapple staying now? Can you see it's staying at the first position now? Great. Or you've gone to bed. Okay, you can see it. So you see that banana, don't shift banana, go front again. Banana don't go second position. Same also, you can put it here if it's here you want to. So somebody gave us carrots. So let's put carrots again. Let's put carrots. Let me copy this code. So which position should we put carrots? Somebody, first comment I see, I'll take it. Which position should we put carrots? Position. No, when you say position, it's different from the index. So if I say position 3, meaning what you are saying is 1, 2, 3. This is third position. But what is the index for these onions that you think this? What is the index? The position is third position. Great. But what is the index? Index. Everybody should say it. Type it. Let me know you really know it. Thank you. Index 2. Thank you. So because this is 1, 2, 3. Fine. 1, 2, 3. Great. But index, if it's the index 0, 1, 2. So we'll put 2 here. You guys are amazing. Somebody say n minus 1. Yeah, very, very correct. Very, very correct. I like the fact that you stick to that formula, n minus 1. What you're just doing to yourself is the perfect way to learn. What you're telling yourself is that I'll count position 1, position 2, position 3, position 4. As long as I know that this is position 4, for me to just get the index, I know that it is n minus 1. So I will know that this place will not be 4 minus 1. It will tell me that this index is, this mango index is 3. That is a very, very smart. Can I clap for people? I want to clap for that person. That's a very, very good. Is this me clapping? Yeah. Thank you very much. That person, that's to show that you are learning very well. I'm happy. I'm happy with that. That person is a very good person in learning. Well done, well done. Yeah. So guys, learn from that. That guy did well. So great. So once we run this code and then come back to print our fruits. Great. You can see now that so carrots is not staying where we have onions. Fantastic. Fantabulous. Let's look at another method called count. Now, what you use count for is to know how many times do you have an item inside your list. How many times do you have an item inside your list? So how many times is banana? Let's not use banana because banana is, let's just try and see. How many times banana appearing in the list? Just one. So let's look for something that is duplicated inside this list. Let's try let's try orange. Let's try orange and count orange. It's saying that orange is appearing twice. Where is orange appearing twice? This is, let's scroll. I'm scrolling from the top because it's the same thing. So let's count orange. This is 1. Oh, let me just do it this way. So that you guys will understand it better. No need to be scrolling. Let me just, so that it will come vertical. Great, fantastic. This is cool. So this is the orange. Let's go. Sure, it was orange we use now. Orange, yeah. So this is 1. This is 2. And now this is 3 actually, but because it's appearing in a list, because it's appearing in a list, it's not coming out. So it's only counting the number of times it saw it on its own. So because this thing is coming as a list, so it's not counting it. Okay, so don't be confused about that because somebody say it should be 3 now. No, it's actually 2. Because this one is counting this index. This is a this whole thing here. We can count how many times this thing repeated in our list. Let's go and count it. So how many times did you see something like this in our list? Let's print it out. It said 0. Why should it be 0? Okay, let's run it this way first and see what will come out. See, 1. It's telling us that I saw this. The reason it was showing 0 because I was using a quote. I should not use a quote because this is not appearing as how do I explain this thing to you guys? This is appearing as a list. This thing inside this thing is a list. I'm telling you the truth. Let me show you something. This is an advanced code. Let me show you something. Let's do something. Type of our fruits in the 0. What is it coming at? What can you see it's showing here? String AB. Great. But let's what's the index of this? So to find the index, I can just write index. Yeah. I think this will work well. Yeah, this is index 8. I just showed you guys that trick. Somebody say why the 0? And what I'm doing here is this, that type. I want to know what is the type. See, listen, is an advanced code I told you just now. This is the type of the variable. But what I'm doing is that what is the type of the item at this position? That's what I'm doing here. What is the type of that item at that position? The type of that item is string. So I want to know what is the data type of this one inside this list now. That's what I want to know. So most of you didn't pick it, but I did it once. I said I can't be counting 0, 1, 2, blah. I just do the fruit index. I wrote this thing out. So it told me the index already. This index is 8. You can go and count it and see 0, 1, 2, 3, 4, 5, 6, 7, 8. So dot index is how you can easily find the index of anything. So let me put 8 here and run it. You see that the data type of this thing is a list. Remember, we said that a list can contain any data type. Same also, a list can contain any data structure. That's why if you go deeper in a list, there's what we call JSON files. And yeah, JSON files. We have different type of JSON files. We have values in terms of the orientation. We have record, values, column, and the rest. So some of you do web or thereabout. If you've seen YAMLs or JSON files, you can see a bunch of, you see list. Inside list, you see dictionary. So that's the complexity in programming. But it starts here, as simple as it is here. Okay, great. So I have to go back because I've done the count. All right, fine. So let's look for, so I'm going to end this class by 10:30. That everybody can go home and rest, and then continue from wherever I want to from tomorrow. Let's look for how to delete an item from your list. So you can delete an item from your list using dot remove. So remove, and then you use the name of the item you want to remove from the list. You get it? The name of the item you want to remove from the list. So what item are we removing from this list? We want to remove apple. Now, when you say dot remove and you write apple, it only removes the first occurrence of that item. So let's run it. Let's print our list. Let's print our list. Let's print our fruit again. Okay, so these are fruits. We have banana. Let's see the first time. This is the first time apple came. Apple came here. And just a minute. Okay, so great. So apple came here, and then if you go forward again, you can see that there's no apple. Okay, there's no more apple again. No. Well, let's remove orange. Since orange came out twice. Great. I want to remove orange. Let me remove orange. So let's remove orange. Fine. So we have removed orange. So I'll scroll this way so that you can see. This is the first time after lemon was orange, but you can see that after lemon, see after lemon there was orange before pear, but after lemon now there is no more orange. But you can see that orange is still showing again. See, orange is still showing here. So what does that tell you? It tells you that when you use dot remove takes out the first occurrence of that stuff. It takes out the first occurrence of it. That's what dot remove do. So it's easy to say, so what if I want to remove all the time that the this thing is fine. You can use what they call control flow and for loop. You can use for loop to loop through. So anytime you see orange, you remove it. Hmm? So we can do something like for. So let's pick something that you can implement that into. So we have how many times did we have lemon? So lemon came one, two. So we can remove that. Don't oh let me first of all clear this stuff. So let's remove this stuff. Let's remove this thing entirely. So let's remove it. To remove that one, we'll do things like fruits, and then we'll do dot remove, and then we'll do let's copy this whole stuff because it's not a string. We cannot put it in index, so we just want to remove the list out of it. So we run it. Fine. So we have removed it. So if you come back and print fruits, you can see that we have removed that. You understand? Great. So let's go ahead to another one. I think I'll do that. Should I do it here now? I think I'll do that later. Thereabouts. So there's another one called pop. So you can also see that we have another one called there. There's another one called pop. What does pop does? Pop is that you are removing something, no, but whatever you are removing is going to save it. For example, you saw when we were removing this thing, it just removed it, and then when we printed that list is not there. But for pop, once you pop an item using the index, it's going to remove the stuff, but it gives you an option to save it somewhere. Let me show you one. Let's practice with this tomato stuff. So let me get the index of those tomato stuff. So index, what is the index of this? Index of this should be what? I just want to get the index. So you already know this, how to get the index of an item. Just do the fruit.index. So this is index 8. Great. So I want to say fruits.pop, whatever is at index 8. Now, if I run it, see, it shows me that T is what is popping out. Fine. But if I come back and say fruits and rerun it, you will notice that, what did you notice? It removed that fruit. Do you understand? It removed that T from the index. But when it was removing it, when you remove them, it bring a command side. That is pop. Pop gives you the ability to save whatever you are removing from your list into a variable. So let me show you an example. So we want to pop banana. What position is banana? Index 1 now. So let's pop banana out of our list. So we say fruit.pop1, that is the index of banana. Put it in, save it inside a variable called banana. So let's run it. Do you know that? Can you see that banana is not there again? From pineapple, look at this part. After pineapple was banana, but now for pineapple is carrot. Abi, banana don't come out. But waiting we last pop come out is still there. Let's say print banana. Let's print this one because now this thing will pop come out for the list. Once you run now, Chase and say they should say banana. So this thing is very important. That even if you are deleting something from your list, pop gives you the ability to save it back. You can save it. That item you are deleting, save as well here. So that's for pop. Then the last thing we can do is there. Now with there, very important. There's two you can delete with there. With there, what you do is this, that you write, this is not a function, oh, this is a keyword, just DEF. You write the name of there, and then you write your variable name, which is the fruit, and then you write the index. So let me go back here. I think this will now be, let me copy this. Let me just copy. Okay, let me just rerun this part again, because it will tell me what is in the stage. Because we still have another T. Okay, 10. So that is the index of this thing. This one is not 10. So I want to remove it. So I'll go to there 10. Now there you don't save it to anything you come out permanently. You know they bring a comma for you. So we don't come out the 10. So we are printing our list now to see the change. So if you come back here and you say you don't come out the 10. That's what it's index for. Then I've not teach you guys slicing, but there, what if I want to remove more than one based on the row? So let's look from here to here. Let's count. If you can't hear me, it's your network. Can you guys hear me? Great. So we have 0, 1, 2, 3, 4, 5, sharing at 5, Apple at 6. So Apple is 6. So here will be 0, 6. This if Apple is, what am I doing? There's a way I can do this thing, but I don't want to do it that for you guys. There's a simple way, but when we get there, you see it. 0, 1, 2, 3, 4, 5. Oh yeah, let me count. This is 5. This is 6. If this is 6, meaning this is 7. This is 8. This is 9. This is 10. Great. So 6. This is 7. So 7 to 7, 8, 9, 10. So 7 to 11. Just follow. Look at what I'm doing. So I'm going to write there. I want to delete fruits. And I want to delete from 7 to 11. You can do it like that. Print fruits. So let's run this code. Look at what you will notice. See, it has removed them. Look at Apple, all of these mistakes that we did that time with extend, and then lemon. So all the mistakes we did with lemon. But if you look at it now, you have Apple, and then the next thing you have is what? Lemon. So what we did here was this: we passed the index. We say, okay, from 7, because this is 6, so 7, 8, 9, 10. But somebody say, but you put 11 here. Now remember range. You remember when you did range, Abby? Remember now, almost they told you that the last number is always what? Do you remember? Well, almost they told you the last number is always excluded. Great. So that is what is applying here. The last number was excluded. You see why we taught you guys step by step, so that you will learn from here to apply here. So the last number is excluded. That's why it's 7, 8, 9, 10. So if you say 10, you go and put 10 here, it will exclude this one. It will only remove from here to here. It will only remove this one. So that's why, just the same way in range, you can do it here. This thing here, we call it slicing. This thing is called slicing, but we'll do it more. So let's see, I'm already doing it here. So let me scroll up. Look at it, slicing. When slicing, note that the value of the last index is excluded, like I said. So slicing means that you want to select more than one attribute. You want to bring out more than one element from your data set. So you want to say, okay, from this row to this row, from that row to that row. So you just say, this is the starting point to, this is where you want to end. So this will give us from 1 to 4. Let's print it out. So it's giving us carrots. Let's go back here. Carrots from 1, onions from 2, mango from 3, grape for 4. It's going to exclude 5, so that's why it's not bringing out sherry. Awesome. So we've done insert already, so I don't need to do this thing. Okay, so we don't need to do this. Then the last thing we should be doing, another method. I've taught you guys index, so you should know index by now. So this is copy. Copy method, very important. Some persons will say, okay, I have 5 minutes or 10 minutes more. So some persons will say, okay, I want to copy this list to another list so that anything I do in this list does not affect this other one. Fine, you can do it. But let me show you the wrong way to do it. This is the wrong way to do it. If we say fruit copy is equals to these are fruits that we have been working with, this is wrong. You don't do it like this. Because if you do it like this, Python saves this to save these two in the same memory location. So what that means is that any change you make to this one, it will affect the new copy you have created. So let's run this first so that you guys will see. So let's print the copy that we created. Can you see that the copy we created is the same thing with our owner? Look at it, fruit underscore copy. Can you notice that it's the same thing, Abby? Now the same I don't go sleep. Great. So the next thing, let me. It's time to on mic now because people can easily go and sleep. Okay. Or everybody be talking so that your voice will disturb your people talking. Yeah, my voice is sweet now. Some people, they don't they used to it. So they can easily sleep on it. But by the time they hear somebody else's voice, fear will catch them, they will wake up once. All right. So let's go ahead. So you can see they are the same thing. They look the same thing. Chidima, you're looking for trouble. Focus on class. So it's the same stuff. But what if we want to delete? Now let's delete what is here. What do we have at index 2, 0, 1 to onions? So we want to delete onions from this one. Oh, this one we just copied. Oh, that we put our normal previous fruits list that we have been working with. Now we have deleted it sharply. So let's print this fruit copy now out. So I'll just paste it here. There's no need printing it. Can you notice that onions has been removed? Now they see them. Hey guys, your mic is on mute. Great. But one thing you should notice is that if we come back here and print our fruits, the fruit will not touch you. Should I say onions don't come up for inside?
Yes.
Can you see the onions? See onions don't come up for inside. Is that right?
Yes.
Before.
Yes.
That's what it. Hey. So that's to tell you that this is the wrong way to copy. Don't copy like this. What I've said just now, I said Python it saves these two in the same memory. So if you do it like that, it's just like you cover something with something. You say you copy it. Not be copy, you copy now. To copy means you carry it, you put it in another place. If you do it like this, it's just like you change the name of the list. I don't know if somebody's get what I'm saying. If you do anything like this, like you change the name of the variable. That's what you are just doing. So the best way to do it is to do what we call dot copy. This is it. If you want to copy a list the way you should copy it, do this thing dot copy. This dot copy is what we actually push it to another location. So let's run this one. We don't copy them now. Great. So let's print fruit 2. You can see that fruit 2 is pineapple, blah blah blah, the way this our previous fruit was. So let's try to remove what is index 1, which is carrots. We use dirty remover. Great. So let's print fruit 2 out. So once we print fruit 2, we do print. Yeah. So that will be easy to view. Great. Once we print fruit 2, you start say carrots don't come out. Look at it. Carrot was there before, but carrot not there again. But if we can't go back, go print our fruits, the normal fruit we do. Show us say carrot still there. Can you see that carrot is still there? Really calm down
Yes.
now. Yeah, please, you guys should be turning on your mic. Great. So,
Yes.
so that's the idea. That's the idea. Fine, fine, fine. You can mute your mic now. So that's the idea of copy. Always use copy. This is very important when you are doing data analysis. Say you go, you want to work on a data frame. You want to now move it to another place so that the one the way your customer give you, or your clients give you, is still there the way it did. So it's, and you want to save that for your code, because sometimes if it did your computer, but you want to just drop it in your code, but you don't want to touch it, so they can easily go back and look at it and say, okay, this is what it was. Instead of going to Excel to go and reviewing it, you use dot copy. Use copy, take copy around. Somebody say, hey, copy they work. Yes, they work. Copy goes. The only place you cannot use copy for, I think you can't use it for tuple. But I don't think you can use it for set, but you can use it for dictionary also. And data frames in Python are dictionaries. That's an advanced way, but it's here from here to there. It's not hard. What will I do in my next 5 minutes? Okay, what I will do in my next 5 minutes is this. Two things I will do in my next 5 minutes. I have 3 topics to teach: list comprehension and how to integrate this. So okay, so fine, I've done this here. I was just doing this before the class. Let's see how you can use if statement inside a list. So this is a two list. You have a username. Let's say you are building a website and people are registering at your website. So they are providing their username. This is where you are storing their username inside this list. So Peter is a username, James is a username, John is a username, Mark is a username, and Grace is a username. Great. So the next thing you want to do is that you want to know somebody, you want to prompt the person to tell the person, enter your username, to know if that person username is already in the system or not. So this is an input statement that is going to carry a username. What this dot title is doing is that anything that it enters into this input, capitalize the first word. Almost I taught you guys this. So that's what I'm doing on this line. Then you cannot check it. So if that username, that's whatever the person enters in this second line here, this line. If that username is, that's or in, whatever not is, in our list of usernames, if the thing is, if that stuff is inside the print, the username is found. That's the username, you write the person username for us. Found, meaning we have it. Now this tab n, this /n is next line. On the next line, instead of doing print username is found, you won't go and write print, proceed to log in. No, you can just do double tab / I'll be /. I think this is / now. Proceed to logins. This title is just to format it to ensure that everything inside this place, it's let me not use title. Title will not work. Let me use title is capital letter. What am I doing? Okay, title is, oh, I'm using Excel, called like Excel. Title is proper, upper, lower. Okay, great. Yeah, great. So let me just use capitalize. Capitalize. Great. Let me use capitalize. All right. So if that is fine, do this. If not, print username. Let me just complete my code here. Username. Then put the username, and then we just write not found, right? And then we can tell the person, let's copy that here. And tell the person proceed to register. Meaning the person should go and register. Great. This is simple code, very, very simple code. So we are using if statement. This is just a simple if statement. You can make it more complex than it is. Then you run it. So it's going to ask us for a username. So let's enter any word. It doesn't have to be a capital letter because we have said that this title here will change it. So Peter, so once I enter Peter, you see username Peter found. Username Peter is found. And then the next thing is telling me is that what? Proceed to login titles. Proceed to login. What if I enter you guys' name? Let me say I enter Victory. Is Victory on the list? Tell me now, is Victory on the list of username? Why you guys mic always going back to turn off? Please, Arise, can you leave it on?
No, no,
No,
no.
no.
No, sir.
Great.
Victory is not on
So
the list.
great. So as you run it, it's going to tell you username victory, not on the list. So we can always do our code this way because I'm using a single quote outside, so I can put a double quote inside so that it will tell me, and I can decide to say, okay, I want to say dot title. So this is where you can have fun with your code. You can play with your code out to show that you just want to play around. So what does dot title do is that is a string. Look about, just read on string. You understand all these dot titles. They are not hard. So username, let's say Peter, let's say James again, James. So it's going to say James, found, and I don't know why I think dot title. So great. So this is the idea, guys. This is the idea about it. Let me take this off so that it looks so neat in your eyes. So let's try it one more time. Let's say peace. No, dot upper will make it capital letter. So you can always try that. Anyway, so peace not found because there's no peace inside. So that's how you can use follow. But let me try another one and then we go. The last one is loop. How to use a loop. Let's use loop. What if we want to use a for loop inside? So I'll quickly just code something for you. Let's say for let's print our list, our list that we'll be using now. We'll be using since fruits, right? So these are the fruits that we have, the items that we have. So remember I told you that if you use dot remove, remember now, guys, is your mic still muted again?
Yes.
So remember I told you that if you use dot remove, it only takes the first item out, Abby. So
Yes,
and I
sir.
said, what if you want to remove all the item? So you can do it with for. Well, first of all, let me show you how to use for loop. So you can say for items in our fruits, print the item out for us. Print it. Let me not say items. For item, so we want you to print the item. So it's going to print every single item inside the list. You see, it's printing it out. So for the item inside our list, I want you to. So it's going to look through the list and be printing the item, printing the item, printing the item, printing the item. What if we wanted to print the index of it? So if we want to print the index, we'll say print the fruit. We want it to print the index of that item. You can do something like fruit dot index. Put our item inside a bracket and run it. So you see, it's printing out the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you see, what if you want to print the count of those things inside the list? How many times did you see that item inside the list? And we're going to run it. So it means that the first item, let's be printing, let's print the item out first. So item, comma, I want you to print the item and then you want us to print the count. So pineapple appeared once, carrot came at once, mango once. So it's telling us that lemon appeared here. Can you see it? And then we have pear. Pear came twice. So there's a way you can do it that this, as far as pear is already showing here, pear should not show again. It should just show you pear number 2, lemon number 1. You can do it. That one is when we are doing data structure conversion. You can do that one. It's not hard. Okay, so let's end by practicalizing that remove. So let's say we want to remove lemon, which are appearing twice. We want to remove lemon entirely from our stuff. So say for item, it can be anything, for S, for Z, for whatever. So but just like item, for item in our fruits, So for item in our fruits, just want to see if you guys are still here. You guys are still here, right? Okay. So for item in our fruits,
Yes.
if you see, I'm practicalizing this thing. If the item is equal to lemon, so if the item is equal to lemon, I want you to say fruits dot remove. I want you to remove the item. See, now you see, I'm now making it more complex by adding control flow and a loop to it. So if the item is inside, remove it. So when you're done, print. Do you see why I went to print the fruits at the end of this place? Mark my look, always watch my indentation. This if is part of the for loop. This remove that is doing is part of this if condition. So when this thing is true, I want you to run this. That's what I'm saying. So if you don't see it, you just leave it like that. So when you are done, print the list out. So let it print the list for me. Guys, can you see lemon again? Eh?
No.
No, there's no lemon.
No, sir.
Okay, can you
No, sir.
see it again? Right?
No. No,
So
we can't see it.
that is the
No.
idea. Yes, that means it has worked now. That's what I'm saying now. It has worked. Let me write fruit
Yes, sir.
on that. Let me write fruit on that so that you can see that. See, lemon is not appearing again. Lemon is not appearing again. Okay, which one do we have that is appearing twice? We have pear. Okay, fine. Let's copy this code. If I want to do function, to just do function, we just agree with just now. With function, you don't need to copy in code, just do it again. So we say pear. Let's put pear here. So anywhere you see pear when you are looking through this, remove pear. So when you are done, let's run this whole place now. See, I've run it. So let me write through. Let's call the list again. Let me do it. It's no, because it's not beginning, so it's not falling to the first side. Anyway, no. Can you see that? Look at the stuff now. Did you see P appearing again? See, look at here. Is P appearing again?
No.
No.
So
No, sir. No,
No.
sir.
So in other words, I've taught you how you can, you see, so what I did here now is a combination of what we have been learning. Your for loop, your if statement, this is relation variable, this is a list. This is a method that we just did just now. I just use this thing to delete an item out of the list. Anytime you see the item inside a list, remove it. That is as simple as that. Very, very simple. So as well as this story, of course, to
Yes, I want to quickly draw attention to something. Yeah, you when the fruit appeared twice, you did the code to remove it. So since it appeared twice, why don't we do it so that it will remain one instead of the two removing?
if I want to do it to remain one, that's another ball game.
Okay,
I don't want
in
to do
that
it
case,
for
in
myself.
that case, sir,
I can hear you. I can hear you.
in that case, you should
I can hear
I
you.
think
Go
you
ahead.
just use the remove right.
you should choose the one of the index you want to remove. Then add it to the item.
And yeah, you can do that. What I would do, there are two ways to do it if I want to do that kind of thing. What I'll do is that you guys, you are drawing from me. Okay, let's do that one. So what we'll do is this. Look at what I'll do. There's two ways. The second way is the easiest way. This one is the hardest way. So I want to show you the hardest way. The second way is very simple, but I can't do it now because you have to finish the data structure class. It's when you finish the data structure class, you now find out that You know how to that is just this simple. So let's come here where we have this inside. You can't fault me, my dear. I know time is gone, but just give us a little bit time. We'll just finish this. I still have list comprehension, so I'll do that tomorrow before we move to the next one. So let's say, guys, don't worry, I think that will be coming. Just wait. Let's say we have a list now. This is our fruits. So I want to set it back to a new variables. So let me do this first. Great. So this is a new list, right? That has duplicates. So let's run it. Great. So we print our list, or let me just write. If we write the fruits, it's not hard. Just follow me. In the next second I'm done. So you can see that we have apple, whatever. Great. So I'm going to do something like this. I'm going to create an empty list called fruits underscore no duplicates or no top, because what we are seeing here is that there's a duplicate here. So I'm going to set it to an empty list. This is an empty list because this is where I want to put all of them that doesn't have I want a new list that don't have duplicate, and I want it to enter here. Great. So I'm going to run this code. Then the next thing I'm going to do is that I'm going to say for item in my fruits, if the item is not what's that word? Not in. If the item is not in my fruits underscore dop, I want you to say fruits underscore dop dot. I want you to append. We use append. I want you to append that item to it. You get it? So this is what I want you to do. So I want to look through the first loop. Now, the item you find in that loop is not in this my own. So please append it. So let's run this code. Great. So let me print fruits now. So let's say fruit underscore dog out and check it. Did you see it again in this place? Huh?
No, sir. No, sir.
No duplicate. No duplicate.
That's it. So what I've done is I've removed all the duplicates here. So and I've added it in this one. So this becomes my new list. So finished. That's all. So finished. So this is the code. All right. So let's share attendance so that we can go and sleep. Tomorrow we'll continue from there. Something else.
It's sharp.
With attendance. It's not hard. It's just for you to sit down and Arize. Boss Arize. Arize, man. Arize. Please, can you send the attendance form? Thank you. So guys, that is it. But there's this thing that looks this so entire stuff that looks so hard. It's not hard. It's just for you to attendance form is already on the comment section. Attendance link. So it's just for you to know how to implement it. So yeah, now I've used append again. See, I use append, and then we've used in. You use not. We taught you not before. The only thing we did teach is in. Well, we've taught you not before. So we say not in. You understand? And then go ahead. Then, but there's a short way. As there's a short way to do this thing. It's just very so short. And if you just do it by yourself straight. You understand? Somebody say, what is the very thing that remove? We've done one in class now. You should understand that there works with index. It removes work with the item. There works with index. We can still change it. If I want to use there, it's another different ballgame. If I'm using there, I'll have to use the index to read the item. And then I use the index to read the item. Then I will now check for where the item is existing, and then do I beg, not everything code this night. Good night, guys. feel your attendance. I'll say to bye, guys. I will see what to you. Please restrict your